Hi everyone, Assalamualaikum and good day. My name is Madam Azida and I will discuss with you 4.0 chemical bonding with subtopic molecular shape and polarity. At the end of this lesson, you should be able to explain what is valence shell electron pair repulsion theory. The next is how to draw the basic molecular shape. We have 5 basic molecular shape, which is linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. And the last one, you should be able to explain bond polarity and dipole moment. For part C and part E will be discussed during your tutorial class. The overview for molecular shape and polarity consists 6 subtopics. First is Vesper theory, 5 basic molecular shape based on electron arrangement, bond angle, dipole moment, and the last one is molecular and bond polarity, which is consists dipole moment, resultant dipole moment. What is actually Vesper theory? VSEPR theory stands for valence shell electron pair repulsion theory. Vesper theory called is electron pair around a central atom will repel one another and arrange themselves as far as possible from each other in order to minimize repulsion. Vesper theory also known to predict the molecular shape from the Lewis structure. For example, we have methane molecule. Methane molecule consists between 2 atoms, 1 carbon atom as a central atom, and 4 hydrogen atoms attached to carbon atom will form 4 bonding pair electron. And when consists 4 electron pair, we produce molecular shape as a known tetrahedral with bond angle 109.5 degree. Okay. The following are counted as a 1 electron pair. So first we have bonding pair. So under bonding pair, a single bond, double bond, and triple bond. So for example, we have methane. Methane consists 4 bonding pair electron. So number of electron pair is equal to 4. Okay, what happens when we have double bond? For example, carbon dioxide. So carbon dioxide contain 2 number of electron pairs. And what happens when there is existing of lone pair? Okay, if we take a look here, for oxygen atom contain 2 lone pair and 2 bonding pair electron. So the total number of electron equals to 4 because of 2 lone pair and 2 bonding pair electron exist at oxygen atom. For Ni3, for atom nitrogen contain 1 lone pair and 3 bonding pair electron. And total number of electron pair is 4. Electron pair repulsion. The force of repulsion, lone pair electron versus lone pair electron, stronger than lone pair electron versus bonding pair electron, and bonding pair electron is weaker than lone pair electron versus bonding pair electron. So the existing is more lone pair electron repulsion, will repel greater than the others. Okay, let's say we have three examples of compound: water molecule, ammonia, and methane. The similarity for three compounds is they have same number of electron pair, 4 electron pair. But there is differences between the number of bonding pair and lone pair present. For water molecule, even though water molecule or oxygen atom have with 4 electron pair, but oxygen atom contain 2 lone pair and 2 bonding pair. The presence of 2 lone pair electrons will repel each other stronger than lone pair bonding pair repulsion. Thus, the stronger repulsion making the bond angle between HOH is 104.5 degree. For ammonia, nitrogen atom as a central atom has 1 lone pair and 3 bonding pair electrons. Because of only 1 lone pair exists as nitrogen atom, so the repulsion only between lone pair electron with bonding pair electron and bonding pair versus bonding pair electron. So the bond angle between H and H is 107.3 degree. Move to methane. For carbon atom as a central atom contain 4 bonding pair. At carbon atom does not exist any lone pair electron. So, the force of repulsion is between bonding pair electron and bonding pair electron only. Thus, the bond angle is 109.5 degree. 5 basic molecular shape. For AX2 represent linear with bond angle 180 degree. For AX3, there is trigonal planar with 1 central atom and 3 terminal atom. If we have 4 terminal atom, the general formula is AX4. The basic molecular shape known as a tetrahedral with the bond angle 109.5. For AX5, that means the presence of 5 terminal atom will produce 2 bond angle. Here is, we call it at equatorial position with bond angle 120. And here is axial position with bond angle 90 degree and the basic molecular shape known as a trigonal bipyramidal. And the last basic molecular shape is known as an octahedral with 6 terminal atom, and the bond angle is 90 degree with general formula AX6. Electron pair arrangement. Electron pair arrangement is used to determine by the number of electron pair around the central atom. Electron pair arrangement, let's say we have geometry is AX2 with bond angle 180 degree. So contain two terminal atom, produce 2 bonding pair electron. So the number of electron pair is 2. And the arrangement electron pair is linear. For AX3, the number of electron pair is 3. And the arrangement is trigonal planar. For AX4 with bond angle 109.5 degree, the number of electron pair is represent 4. And the arrangement, we call it as a tetrahedral. For AX5 with 2 bond angle, the number of electron pair represent 5 and the arrangement as a trigonal bipyramidal. And the last one is AX6 with number of electron pair is 6 and the arrangement is octahedral. This is linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Bond polarity. Atom with different electronegativity form polar bond. Next example is between carbon and fluorine. Carbon is partially positive while fluorine is partially negative. So, fluorine is more electronegativity than carbon, and polar arrow will show from carbon to fluorine, and the bond is polar. What happens if we have the same electronegativity? For example, we have carbon. 2 carbon attached and make 1 bond. And if this is happen, the bond is nonpolar. For bromine 2 gas attached with same atom and same electronegativities, also we produce nonpolar bond. Okay, we have exercise 1. Use a polar arrow to indicate the polarity of each bond. And the second one is rank the following bond in order of increases polarity. Okay, the first answer is between nitrogen and hydrogen. So nitrogen is more electronegativity than hydrogen, so that the polar arrow will show from hydrogen to nitrogen. Fluorine is more electronegativity than nitrogen, so that the polar arrow will show from nitrogen to fluorine. For ICl, the similarity between iodine and chlorine is they have same group 17, but different in period. Iodine at period 5, while chlorine at period 4. Across a period, the electronegativity will increases, but down to the group, the electronegativity decreases, so that the polar arrow show from iodine to chlorine because chlorine is more electronegative than iodine. For bond polarity, the increasing order of bond polarity is the bonding between H and O is stronger than H and N and C and H. Because of oxygen, more electronegativity than nitrogen atom and more electronegativity than carbon atom. Molecular polarity. Net imbalance of charge. Electron-rich region, partially negative, and electron-poor region, partially positive. Quantitative measure of molecular polarity use dipole moment. Dipole moment or mu with the formula Q multiplied by R, which is Q is equal to charge, while R is distance between charge. The unit is in 1 dBi. So 1 dBi is equal to 3.36 times to the power of negative 30 coulomb meter. Resultant dipole moment determined by molecule shape and bond polarity. If the value of dipole moment greater than 0 or not equal to 0, the molecule is polar. But if the value of mu equal to 0, known as non-polar molecule. Polar molecule is actually, we call it unsymmetrically molecule or unsymmetrically compound. For example, the polar molecule in the geometry, we call it as a seesaw, band, T-shape, and etc., which is unsymmetrical molecule. But for non-polar molecule, for represent the 5 basic molecular shape: linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral, will produce resultant dipole moment equal to 0. Question first. How many pairs of electrons are shared between two atoms joined by a double bond? The answer is 2. Which of the following organic molecule has a trigonal shape? Trigonal planar shape consists three electron pairs. So I'll give you the clue. To answer this question, first step you need to draw its molecular shape. And from here, you know which one is represent trigonal planar. Question number 3 is the electronegativity of some atoms are given below. Which of the following one is the most polar? The answer is C. Because the highest electronegativity is fluorine. So that's all for today. So we will continue to the next lesson. I hope you will enjoy our lecture today. Thank you.